Welcome to the ASIC LS tutorial series, Analogue IC Engineering for Engineers. My name is Robbie Robinson and I'm a Director of ASIC Layout Services. In this first tutorial, I will help you to remember everyday semiconductor atomic numbers with ease. Actually, the only thing that I want you to remember is that the atomic number of silicon is 14. So let's look at how a silicon atom is constructed. Firstly, we have a nucleus or a core which contains 14 neutrons and 14 protons. Then, circling around the outside of the core is 14 electrons. The 14 electrons cancel the charge of the 14 protons, so the overall charge of the silicon atom is 0. Now these 14 electrons are divided into two shells. The inner shell has 10 electrons, which circles around the core, and the outer shell has 4 electrons, which circles around the core and the inner shell. If you think of the number 14, it's made up of a 1 for the tens column and a 4 for the units column. This should help you to remember which electron goes where. Now this outer shell is divided into two energy bands. The inner energy band is called the valency band, and the outer band is called the conduction band. The 4 outer electrons normally circulate in the valency band, unless some external energy, such as heat, is applied to the atom. The result of this additional energy injection would be that one electron would move from the valency band to the conduction band, and there it can be easily pulled off to become a negative charge carrier. If the electron was pulled away to form a negative charge carrier, it would leave behind a hole, and because there's less negative charge in the entire atom, then the charge of the entire atom is slightly more positive. Now because there are 4 outer electrons in the outer shell, this atom falls into a group called group 4. That's the same name as the security firm, of course. That will help you remember. On either side of group 4 is group 3 and also group 5. As you can guess, if group 4 has 4 electrons in the outer shell, then group 3 has 3 electrons in the outer shell, and group 5 has 5 electrons in the outer shell. Because group 3 has only 3 electrons in the outer shell, it is considered to have a hole which will readily accept an electron, and so elements in group 3 are known as acceptors and have an overall positive charge. Group 5 has got an extra electron in its outer shell, and so it will donate an electron easily, and so elements in group 5 are known as donors. And so the extra negatively charged electron gives the overall atom a negative charge. Returning to our discussion of group 4, also included in group 4 with silicon is germanium, also carbon, which is what we humans are made of, and also tin, which is what the Tin Man from the Wizard of Oz is made of. The group above group 4 is group 5, and to help you to remember the elements in this higher group, you can think of the acronym PAN, because a pan sits on a stove and heats up. So PAN helps to remind me that phosphorus, arsenic and nitrogen are in this higher category, group 5. Also, for phosphorus, you can think of phosphor glowing. Again, this helps me think of something more, and so indicating this higher group. Also, nitrogen is combustible, and again, to me, it also associates itself with the higher group, and arsenic has a big reputation for being used as a poison. Now, to help you remember which elements are grouped in the lower group, group 3, if you think of the acronym BAG, because when you carry your heavy shopping bag full of groceries, of course it hangs down low. Now BAG stands for boron, aluminium and gallium. Boron sounds like the word boring, which indicates a low attention span. And when I say gallium, I tend to say it with a deeper sound. And finally, aluminium is a dull metal. Now if we relate everything that we have just learnt to the periodic table, then we can see that if we add the 10 electrons from the inner shells to the electrons in the outer shells of groups 3, 4 and 5, then these groups relate to the atomic group 13, 14 and 15. So that's it for this first tutorial. Remember that all you have to remember is 14 for silicon, and you can work the rest out. Practical applications of the information discussed in this first tutorial can be found in further tutorials in the series Analog IC Engineering for Engineers, available from www.asicls.com.